with the we held up with the other important concepts, probably mean, median, mode, and then we proceeded further with the advanced statistical concepts that could include even the hypothesis testing, that could include what is the standard deviation or variance and other aspects as well. So I think Anshika joined the session. So hi Anshika.
Yeah, good evening, sir.
Very good evening. So what I'll do, I was just trying to give the background on what all we covered till now, and what all we are going to cover from now on. So what I'll do, probably I'll just go on mute and I'll give you the stages of yours, Sanchika.
Everyone, how are you all doing? I hope everyone is being safe and doing good in their life and amazing with their journeys also. So today we will be revising the concept in the what we read last day. And even though today we're gonna learn about the experiments and what is the real time, what is the real life example of different categories we read about: hypothesis testing, then standard deviation, mean, proportions, okay, and then the central limit theorem, okay. And even though what else we gonna do is I'll be sharing most of the examples what I have been prepared and everything. Okay. And after that, we will be learning what is actually the application, what is the importance, why we all are being focusing about the central limit theorem, about that stuff of your then standard deviation, then actually what are the basic advantages of that, okay, and the significance testing also we're going to study about. So let me share my screen and very quickly we will be having a quick revision of our concepts. I hope my screen is visible.
Yes, it is now. Thanks.
Okay, thank you. So we read about what actually your statistical is all about and how your statistical are being given a basic proportion of it. Okay. And very simple definition. I actually told you a very simple definition about that, about the statistics, which is just like single words and the more the often of it. And it was like statistics is actually your uh, the mathematical discipline to collect, to summarize your data. Okay, and you're summarizing your data and to collecting your data. This actually means about that you have more acknowledgement about what your data is all about, okay, and how your data is gonna share with other numerous part of your lines, sublines of that, okay. And for data science, already your statistics should be very much important, and this is actually designed in such a way where all your principal statistical methods are there, then your procedures are being there to use wherever your data analysis are being used, and basically the tools what we have to use in that, okay. And like now I give you an example about the data analysis only. So in data analysis we require a descriptive statistics and we need a probability in that, okay. Whatever the minimum knowledge we have about the statistics and a probability, we need it, okay. And every concept has been comprises of your better decision from your data, whatever the better decision are being there, and however your decision are being taken in substances in that, okay. Regarding the problem and what is your implementation and what is your applications of your statistics, these we are going to learn about. So moving forward towards the what is your sampling distribution. And again, I'm repeating the sampling distribution because it is very much important. And in sampling distribution, you better know, like, if it is not given a proper that part of your executions and equations, so it will not execute it. Okay. And simply manner, just to remember, see, you don't have to cram all the definitions. If you have been cramming it, you're not learning it. Okay. You just have to remember, okay, statistics is what it is. Statistic, it is a collection of your data. It is like ordering your data and everything of it. And just like the sampling distribution, you don't have to learn about the sampling distribution, the definition of sampling distribution, about the 4 to 5 lines. No, just remember, okay, what is sampling distribution? It is just a probability of your distribution, which is obtained from larger number of samples to the specific population. Just remember, just remember the example of your home. Okay. And in the previous times, you have like joint families comprising of 30, 35, 40 members in each of it. Okay, even the 50 members of there. But now, what the modern families and what that small bunches of families are actually, what number of members are there? Either 4, either 6, or either 7 in that. That's it. None of more than that. So that you have to remember what is sampling distribution, like from large number of that population, or the large number of samples taken, individual as in sample. That large number of that population is divided into specific population. Okay. Now consider, like, you have 10 kgs of apples. Okay. Now in 10 kgs of apples, they are being boxed in 10 kg. Okay. And they're packed in it. Now, if you have to divide it into perfect, okay, you have a 2 kgs each of the boxes of, okay, and there are 5 boxes, 2 kgs each, okay, in each of the box. So that is from large number of ample of your product or any of that. You have that you have been like divided that part into 5 equal number of then boxes in that. Okay. From this how you is actually the sampling distribution definition is being done. If you remember this example of apples or the large families, you won't be like losing it for the longer term, the definition of it. Okay. These all of your, like, I gave you the example of your population and everything. These all have a larger frequencies of whatever the range of it comes as an outcome part or as in statistics part, and a proper population in that. Okay. So in the sampling distribution, so very known example of sampling distribution over here is between the part of your graph it is mentioned, and it is between your probability and mean. So over here, what it is happening. Okay. So these like it is 2 and 8. These are 2 over here on the very left side. It is unlikely outcome. Okay. And over here, again, it is unlikely outcome. But what happens now if you have an average value and your each and every, see over here, let me just share the screen and make it as a pointer. Okay. So over here, each of your these parts of the graphs will be raised at this point, as in this point. And after that, it would have a curve. Okay. Like this, it would have a curve. And it will, like, I'll just give a final execution. Ignore my drawing first of all. Okay, so these how the graph will be made upon. Okay, this is the bulge out of it, and these are the basic agenda of it. Okay, this is your average and unlikely outcome. These both are your unlikely outcome, this part and this part. These both are your unlikely output in that. Now, what is your average in that? Now, what is your sampling distribution? Your sampling distribution is just and just your statistics across an infinite number of your samples in that. Okay, and infinite samples, it would be taken as x bar or any of your whatever manner it can be taken, or any of that. Okay, now we take many random samples of a given size n, or suppose these are being taken as a value of n. Okay, and these are being taken as a value of x. So what it would be happening about, it will be giving as a sample distribution of your x bar. So these will be your sample distribution, what of it will be x bar. Okay, so it would be x bar, and after that it would take a basic proportions, where it would have that what we can say, that it would have one of the finalizing point. These are the final, let me change the color. So it would be your your highest point of view. Okay, and that is the simulated sampling distribution. So here the points would be getting decreasing until it becomes your unsimplified, uncounted or unsimplified outcome. Okay, we might be having these also. Okay, either less than that also. So these, whenever, so we can use that as a normal model for different scenarios. Okay, as in z scores or any of your alphabetics or any of your or we consider it as an area under graph. Okay, so area under graph, it actually means about the performance of your estimator. Okay, and the performance of your estimator will depend upon the number of sample means in that. Got my point? So now the basic the basic 3 points to remember about the sampling distribution is, first point is it has to be taken, or it has to be selected as a random sample from a specific size in that. Second, you have to calculate a statistics for the sample outcome, such as your mean or your that standard deviation or any of that. Either median should be there, or mean should be there, or any of your standard deviation in that. So it might be get affected or any of that when you develop such theories, or develop the basic outcomes or any of that with an approximation symbols. Okay, and approximation symbols would also be giving us as in the third point outcome, that is you develop frequency distribution, or to develop the basic knowledge or the basic resources for your the distribution opted for your each and every step you have been calculated through. Okay, now what is like in a real life example of your sampling distribution, I already gave to you yesterday also, but still I'll be repeating for that. I guess there should be any lag or any of that yesterday, so those who have missed it, so I'm repeating it again about the one of the example I gave you about that part of your in the real life example about sampling distribution. So I gave you an example about like if you have if you have to get a survey. Okay, suppose you are getting a survey of how many, it is 100 polls of your survey. Okay, 100 polls of the survey, and that survey to whom you have to dedicate it, like we have to repeat the surveys each and every time. Okay, now for that, what possible outcomes or what possible samples should be there? For example, is like instead of asking people or the population to poll for certain times. Okay, now we have two animals. One is cat, another one is dog. Okay, now if we have to feed them, so they have a food, so they have a food, we don't know like if the cat has the same food as of dog or not. Okay, now see, these 100 servers we have to get it, and for cat and dog. Now if cat has another food and dog has another food, I just know about the dog only. It's a doodle, or a doodle for the dog. Okay, so what we can do is, for dog it has a different food, we cannot add it in cat, obviously. So if we cannot add in cat, so we have to get it another one. So there will be two categories of your food. Similarly, it has been both of them are being relating to the terms of animal. Okay, to the terms of animal, but to the terms of animal, these do not have the same food. So from large object, the root has been same and everything is, with the categorization is being difficult and different of that. So as like the food are being like when what the cat food is there, the pet should prefer it. Okay, and accordingly the matches should not be same for cat and dog repeatedly. So the polls will be different, and the multiple times the polling will be happening out. Okay, at the same time we cannot give a single food or any of that in the one criteria point. So similarly to the types of your distribution, what are the types of your distribution and every of that, and the type of your distribution. First of all, the type of your distribution is your mean. Okay, and the sampling distribution of your mean. And in the sampling distribution of your mean, what it happens is, basically, if you have to take an example about what the sampling distribution of mean it is. Okay, I'll give you one example about the sampling distribution of a mean. And first of all, the definition of it. So we know like what is sampling distribution of mean. It is just in probability distribution of each and every statistics to be obtained from larger number of samples drawn from a specific population. Suppose I drop that dice. Okay, now dice, what outcome I will get it? 1, 2, 3, 4, 5, and 6. These will be my sample outcomes. When I throw it, or sample spaces. Okay, when I throw a dice. Okay, what I'll be getting is, when I'll throw a dice, I'll getting these sample spaces. Now if I have a probability of getting only 2. Okay, if I'll write like what I'll be getting from A or B, or just simply write what is my B, and I'll write it like what is the sampling outcome of 2. So what it would be? 1/6. Okay, and similarly, if I write the same about 4, 5, 6, any of that, I'll get the same output of this. Okay, similarly to that, after I'll told you these examples also. So similarly to this, if we have calculated the mean of each and every samples, or each and every ranges of possibility, or the outcomes of your statistics, it would be either mean or mode, or some of the variables in that. But that part of your probability would actually exist. Okay, the probability of will exist as a population part, or as a that sampling part. Okay, now another one is, I have an example for this. We will do it later by the end of the slides. Okay, now suppose if I have basic standard of it. Okay, so let me do one thing. I'll explain you these examples also. Slides. Let me open one slide over here. Okay, so suppose I'll give you one example about, this is for that sampling distribution for mean. Okay, this is only for mean. I hope you are being knowing this or understanding my handwriting. So I'll give you one example about, like, I have a graph. Okay, and that graph has a bulge out as in these bar. and this is the graph of it. Okay, if the midpoint of this, or the standard part of this is 10. Okay, so what it be happening about? Okay, now if I'll be applying central limit theorem also, and both of your that part of your mean also. Okay, if I haven't given as a proper sample or any of that, suppose if I have given the basic execution also of your sample. Okay, now for your basic proportion, and your sample has been given, and that sample is also given, this is as given as mu, and this is as given by mu x bar. Okay, this has been given as a mu and mu x bar. Now I have a value about that. Mu is equals to 10, the proportion. Okay, any of that, or we can take an the sample value as mu x, the value x bar. Okay, don't use x over here. 8.5 and 9.1, 10.3. Okay, these are the values. Now, if I have to get the value obtained by these of the structure, so in this we know that mu is equals to mu x. Okay, by the theorem, what you can actually know about the mean of it. Okay, if I have a random sampling in the, suppose if I have given a condition that you have a random sampling, that you have a random sampling, second, if I have an idea about normal conditions of it, what normal conditions are there? Normal condition. And third, if I have an independent conditions. Okay. If I haven't that independent condition. So these three of your condition matters. First of all, random sampling, second normal, and third is independent. In the normal condition, it actually matters what distribution it has been given as a normal or as in that is standard normal. Second, we have to know about the at least samples of it. Okay, and in independence, we know we want that if your samples can be replaced or not. Okay, suppose if it can be replaced, and your structure should not be changed in that, so this is only and only better for us only, because if it is not given with the duration part or any of that, so it won't be knowing the better part of it. Okay, so that is what I'm going to explain you. I'm just explaining you how your the basic exactions are being given as in such a mean value. Okay, another example we will be doing is, so I'll repeat it for you what examples has been there, so that we can just change it. Okay, so I'll repeat it, just listen it carefully about the example. Okay, so I'm writing, still I'm writing that on basic values of that. So the question is, the average made and the average male drinks only and only, okay, average I'm being saying, the average male only and only drinks or have 2 liters 2 liter of water when active outdoor, with any of his standard deviation is 0.7. Active standard deviation is 0.7. Okay, And if you're planning a full day nature trip for 50 men, okay, how many men are there? There are 50 men. How many? There are 50 men and will bring 110 liters. Okay, average used to drink 2 liters, and there are 50 men who will bring 110. This is given. Okay, they will bring 110 liters of water. So what is the minimum and what is the probability that you will run out? So what we have to what we have to get through is what is the minimum and what is the probability that we have to run out to that. Okay, now how you make a graph of it. So just I'm making random of that. I'm not taking proper execution or any of that. So this how the graph would be. Okay, or much better than this. So this how the graph would be. And suppose we take this as in 2 liter, the mid of the 2 liter. This is 2 liter. And after that, obviously it would be starting from 0. If this is 2 liter and we know what is the standard deviation or the midpoint of that is mu, and if we've separated or we have taken these points as an expected, okay, these part as an expected. Now if we apart them, suppose if we apart them, both of it, if we apart them, so this would be our this. Okay, now we have to calculate what is the basic probability that would have to run out. Okay, we know we have given that your basic mu as in 7, and this the sign part as in 0.7. Okay, we have given 0.7. Now we have to know about what we have been given. We have to get that p run out. P run out. We have to calculate. This we have to calculate. Okay, and P, these part 50 part has been given to us, that is 110. Okay, now P average, what is P average? Now the P average, average water used per man is, what is the average water used per man is? I'm just writing a average water used per man. Okay, now what it is being used by? This has been given, and 2, an average would be the 2.5 liter per meter. 2.2. Okay, it would be 2.2 liter per meter. Okay, there are 50 men. Try to understand it properly. There are 50 male that have brought 110 liter of water. Okay, now comes very interesting part. Now we have to get the sampling. We know that what is the sampling distribution of the sample mean, where n is our, this is our n. Okay, and we have to calculate that. We have done it, and we actually have to calculate what is the probability that you will run out to get that. So mu x is equals to mu, and that is equals to 2 liter. Okay, what is it? Has been taken to 2 liter. And what happened? We have to calculate this, and we have done it. So this is equals to this. This is the formula. Just remember, we have read now only. Sorry guys, it is not 6. It is symbol n. It is square, sorry. So now what is this part? This is 0 0.7, 0 0.7 का square divided by n. What is n? Tell me what is n? It is 50. Okay, and it is 50. So what is 0 0.7 into 0 0.7? That is 0 0.49 divided by 50. 0.49 divided by 50. Now what is 0.49 divided by 50? That is 0.098. What is, the answer would be 0.098. If you have to square it also, but there is no need of it. So the answer would be 0.098. Okay. So this is what, and obviously this is what it is. It is the probability that you will run out. Okay, and probability is always and always less than 1. If it exceed your 1, your answer is wrong. Okay, your answer is not correct if it is exceeding your 1. Okay, I hope it has been clear. So what is the importance of your sampling distribution? So very first importance about the sampling distribution is like it is given as a statistical formation and the statistical font of it. Okay, and whenever the points are being given, in your sampling distribution, either it is t distribution or it is t distribution, either that is the mean or standard deviation of it, or any of your proportion, any of that. So it is much more important in your inferential statistics. Okay, in practitioner world or the practitioner world, everyone has to collect the data. Okay, if I have to if I have to generate or any of, if I have to make that any of your product or any of the, what example we can take in this is, okay, if I have to make a chair, okay, I have to collect, first of all, what I have to collect to make a proper chair for my home. I have to collect the furniture, okay, the instruments, that tools to cut it, to blend, that make a shape of it, that carving, any of. Second, third, I have to get that pins, okay, the iron nails of it. Okay, third is I have to get that. Fourth is I have to paint it also. So for the painting, I have to get a color and that paint brushes. Okay, these are the 5. Then only like I'll be able to make that tune. Similarly, if I have to get that sampling distribution, any of the importance of any of that, you have to first of all get the data. You have to collect the sample of your data, and for these, each and every estimated parameters are being given in proper distribution. Okay, hence your inferential statistics, inferences used to make your population, overall population of it. Okay, now if I talked about, like, if I have to calculate the random analysis of your sample from any of it given population or your distribution, it has to lead for, first of all, it has to lead to revelations or any of that to correct, to make a numerous fields of your data. Okay, if I say like, okay, my phone number, I have a bunch of phone numbers and everything, and instead of my names, I'll adjust phone number. So it is not possible. Yeah? Under the field of your phone number, the phone number will come. Under the field of your names will become. So that how it has been taken a point in that. Now comes is your central limit theorem. In central limit theorem, first thing you have to remember is that it is just and just what you can say, that it is just a mean and the standard deviation, which is taken as a sophisticatedly a larger value, a larger random samples, a larger mean approximations, or it is normally suitable, or any of that. Okay, it has been given a lot of your independent random variables. They're being summed up. Okay, each and every distribution is being originally verified. Okay, and these are being normally distributed too. Whenever the sample size increases or any of that, your standard for decreasing is being there. The standard deviation would be decreasing. Wherever it has been increasing in your sample size, your standard deviation has been decreasing throughout. And hence your center of your that your these are the sample of your, so here is your, here is your sample. These these are the basically high point, and these the high point. It is mean the actual mean of your that situation. It is actual mean of that situation where it has been come through. So here the graph would be going about. These are the structure of it. It is not up to that mark, but the shape would be these. The shape would be taking the touch point of your highest number of your whatever there is, the point is it is, or any of that, the highest point would be that only. Okay, and after that, the point, it has to evacuate, or it has to get it through. It is the similarly to the point of evaluations in that. So here is similarly I gave an example about whenever you roll your dice. Okay, die. Okay, when you play Ludo or any of that, either or simply you have to just you throw the dice. Okay, and while throwing your dice, you have an outcomes. That is 1, 2, 3, 4, 5, 6, any of it. Okay, and when you have to come take out the any of your samples in that, or the approximations of it. So what you do is you have to just take it out as in sample variable mean in it. Okay, and the sample variable mean, the result would be either from one die or it would be as an uniform distribution or a sample. So here, if you have to roll, just a second, if you have to, you rolled only and only one die, so outcome would be up to 6, and that too uniquely. And now, when you do the two dice, so one would, how many times one would come, then two, then three, and four, and the double time it would be outcoming. Similarly to three dice, it would be one would become three times, two also, three also, four, and simultaneously five and six. Okay. Now again with the five dice. Now see what the sample size would be increasing as we generally go to 1, 2, 3, 4, any of that. Though the sample size has been increasing, and the mean of your sampling distribution will more likely look like a normal distribution. So see here, no graph is there. Okay, so there we cannot see any graph in here, and then this is here the little it is building. Okay, here the little part it is building. Okay, and then it is generally decreasing. In third also, just take a look how the graph is being like growing and like falling down. So here again, the shape of your graph is eventually it has been fallen with a more peak. Okay, now see the lowest unfitted point. So now check in your that five dice. In the five dice, you have more clarity about the normal distribution. In the five, in your 10 dices, you have a better idea about the graph peak, how it has looked like, or how your theorem is now satisfying basic idea of your that distribution in that. Okay, we actually read about what the central theorem is. It is just construct a sampling distribution of your mean. That's it. And these theorem will ideally show your, or it will presented your how the shape of your sampling distribution will normalized. Okay, in similarly to that, here your shape is not normalized. Here a little change is being there. Then again the peak has been raised. Then similarly we go up and up, and this is the proper. This is also we cannot say that it is the proper shape of it. Either we can go to 11, 12, or 13 dice also. It would look more better instead of this. Okay, so this was the motive to tell you about the graphics and everything. So now comes a very important again, the hypothesis testing, and which is like my favorite, and it is actually important to know about what is the hypothetical thesis testing, because there are many exams and many of your proportions and everything which they actually ask you about, like what it is and how you can present that. Okay, and presenting that doesn't means like you just have to learn theoretically and you just have to know about what it is and how it has been performed. Okay, you just have to remember few points about like how these actually are being given as in proportion of it. Okay, just a little part of it, and that's nothing to hurry or any of that. Okay, now what is your hypothesis testing? So hypothesis testing is just in form of your statistical inferences. We'll read in the last slide also about the center limit, and about the hypothesis testing. One thing I would like to tell you about what is the fun fact of this, and how we can actually progress it with a just like the simple examples. Okay, knowing about the hypothesis testing, it is just in testable. It is used as a just in testable on the basis of your observed data. Okay, and your that has been modeled also as to realize a few values, or to give an as a few collection points, or the collection of your random values in that. Okay, nothing such that. It is just and just about the addition of your population mean, or a hypothesis testing, or the procedure of it. Know about the parameters. So what is the parameters? Parameter is your variance, your proportions, as then standard deviations and the medians. Okay, this all hypothesis tests are being concluded and are being conducted in regression and correlated to analysis. Different types of term determines which is used in your regression relationships, and these values are being obtained as a random value, as a variable. Okay, another very simple which I used to prefer the definition of the hypothesis testing, that is it is used to analyze the test as an assumption regarding a population parameters, just to remember lengthy theorems or any of that, or these point of your statisticals. Just remember that it is just an analysis test that has been as an assumption regarding a population parameter. And what are the parameters? And the parameters, we know it is proportion, it is variance, it is standard deviation, and it is the median in that. Now let's know one of the very good hypothetical what it is. Just let me let you know. Uh, just give me a minute. Yeah. So this is very much important chart, which you actually have to remember about what your hypothesis testing is all about the charts or any of that. We all know, like we all over here, we know about why we been learning the statistics. We actually learning about the statistics, like we know it is just all about the data, and over alone it is not basically happening interesting. Okay, and we have to remember certain points where the parameter are being given as in the space in the spatial part. Okay, so what I have to give you an idea about. So we know, like over here, these are the three graphs. Okay, this is one, this is two, and this is three. There are being three graphs, and these all are being evolving, like the building of your basic shaping of your data. Okay, and whenever we want to make these graphs as in sample data, or to interpret it, or any of you draw, or we have to draw the conclusion of a population, and any of that, or the sampling data, so we have to claim it as a distribution data, which will result in different sets or different uh, applied machines or any of that. Okay, so we know about the parameters and the statistics. And a parameter we learned about, like it is just in fixed characteristics of your fixed characteristics of your the data undertaken. Okay, and in the that part, mean has been there, variance has been there, standard deviation is there, and proportion has been there. So how your mean is being denoted? Mean is denoted by mu. Okay, then variance is denoted by this sign, deviation as well as this, and proportion by pi. If you don't know, just remember this off, like it is important to know about. Okay, these are the tests are being given about the tail testing, the hypothesis testing, and the. So now here in the first graph, what do you know about in first graph, and how you have to configure out like what is interesting or not. So over here, the first one, it is just a real tail test. In this, we know about that HA is been as an UI is greater than your value. Okay, so these part would be colored off as an HA is more probable in this region. Okay, you read about in the very first class about the right tail test and the left rail test. Okay. Over second, the H is more probable in your, it is in less than. Over here it is greater, and over there it is, if it is being greater, so it would take the right side. Okay, if it is being less, it would take the left side of it. If a that HA and a mu that is not in equals to the value, so both over the side left and right would be the place of your HA. Okay, these both would be the place of it, not the single part, but the both of it is been greater, the actual value of your value, and HA would be greater and less than would depend upon the what side it has been probable expected. Okay, so then let's move forward about the sampling sampling testing. About the sampling testing, you know, one point has been given, and that point has been able to define that what that point has been the static part of it. Okay, if I'll give you one more example about, if I give you one more example of hypothesis testing, if any one of you has not been clear. Okay, I'll make a graph over here. If anyone over here is not still cleared of any of that, let's understand it. Just give me a minute. Okay, So let's learn about that only, and I'll give him a more example. Let's draw a graph. Okay, so let's have a graph, and suppose this is my endpoints. Okay, I'm just explaining you in the B part. Okay, so these are the graph of it. Suppose if I give an example about the regions or any of that. Suppose these are the critical and you're confident about the confident region. These are the critical regions, and these are the confident regions. Okay, this is critical, similar to that, vice versa. So this is critical and this is confident. Okay. Okay, this is confident and that is critical. Now, if I give in an example about how your point has been rejected and any of that, and example to be given as in like how your greater, equal, and the real test are being performed such. Okay, if you don't have any idea about the greater or less than or the availability of your the structure. If I see you like it is 99% of the confident region, and this is only and only like just remove it. If I'll tell you only the right part of your has given as a real test of your 0.01. Okay, it has been given as a 0.01, and you have to do one thing. You have to calculate what is with the number of minutes or any of that, what is greater when why the what it have the value or the greater than any of the value of your right tail test. Okay, you have to give the idea about that. I gave you the information about the confident region. I give you the information of that. Now you haven't I give you if the value of your any confident critical region or any of your that is 70. Okay, if h naught and mu1, h naught and mu1 is equals to 70. What it is 70, and after that h1 and mu, sorry, it is not 1, it's only mu. H1 and mu is again greater than 70. Further it was equals to, now it is greater than. Okay, we have to now like we know like it has been a value would be this value would what this value would be, it would be the 70. Okay, what this value would be, it is 70, and after that a critical point that is 0.01, and your critical zest should be equals to, this zest should be equals to 2.33. Okay, it is 2.33. If I say you that you have to apply the z test over here, this we have read about the z test in the very first class also, and yesterday also I repeated. If I have to calculate the z test is equals to, and the formula I write it x bar minus mu, that is okay, and under root of n, and I have to write the value of that. That's 75. The 75 is the actual the regression point of it. 75 minus 70, that is the value, divided by the sign. What is the sign of it? The 10, the basic 0 point part, and the root of your 30. Okay. Now what would be? What is this? It is 5 by 2. It is 5 by 2. And what is the answer of it? It is 2.5. And it is believable to left side of the declamations and reject HO. Okay, it has been rejected HO, and the greater than, it is actually needed as a 99% of your confidence in that. Okay, and it is the confidence region. Similarly, if we change the values, you have to calculate that whether H naught and mu has been equals to 0, or H1 mu is not equals to 0. Okay, you have to just judge out these two regions, left and right tails. Okay, that's it. Nothing else you have to remember of. If you have the most points about the categorization point, or the execution point, you just have to remember that it is just an given as an the status part. Okay, now there is few tests also in your hypothesis test, that is Z test, which we already did. Then there is a critical value test. Then there is that computational test, and further it is one more. Just remember about that example about the hypothesis. So the hypothesis example, just remember. Sorry. So just remember about the hypothesis test, that is Z star. That is Z star is equals to X bar. Just write it anywhere you would like, because it is many times it actually we used to forget this. And if we are forgetting this, so nothing would be helpful to us. Okay, X minus mu, oh sorry, I just erased the bar also, divided by this by under root of your n. Okay, just remember this, all the one-sided that formula and everything of the hypothesis testing. This is the main formula and the main judgmental of your hypothesis testing. Okay. I hope it has been clear to you. Any doubt to anyone till here? Is there any doubt? Let me know.
Guys, if you have any doubts, probably this is the right time to ask. I think this is the second time that we are repeating some of the points which we discussed earlier. So probably we may not be able to discuss the same at length in the coming sessions. Murli, do you have any queries? Okay, fine. I think we do not have any queries as such. So probably what we'll do in the coming sessions, we'll try to pace it up a bit, and slowly and steadily we'll try to see how each of the concepts are being used in real time as well, right? Okay. So probably in Ashika, in the coming sessions, what we'll do, we'll try to take up some of the problems Okay, and help our students to see where these concepts will be used.
Sure, sir.
Right. Sure.
Sir.
Okay, thank you guys. Thank you for joining today's session. Have a great day. Thank you, Anshika.
Thank you, sir.